Hello everyone, hope you are doing good and welcome back to my channel. Today we are at Daily Code Challenge day 15 of the April month 2024 and we have a question on the trees. It is a medium level question. Let's see what can be done here, okay? So I will again repeat like from the last few days we are getting lots of question on trees. So see this just tries to show you that how important these things are, okay? Because it's worth, that's why Leetcode is also focusing on this. So see if you are, just want to learn anything, we'll have to learn it to a level where you can clear interviews, right? So this is one of them. Okay. You see, these questions are actually simple, but you will see that these are marked at medium level because see, many people do not know this. Okay, this question should be called as a easy level question if you know the full concept of what is a tree and what are the various traversals of it. Okay, if you even know that concept, I'm sure that you will call this as easy question because there is nothing much edge case here. Okay, we'll see that now. But see, my idea is very clear. Please try to learn what are the concepts of trees and the various traversals, okay? Because till now whatever I have seen in this April month daily code challenge, most of them are revolving around this topic only. So this was just a gist of what we have seen previously. Now coming to today's question, okay, it's question 129, some root of leaf numbers. They have given a lot of things, but let me give you the gist in general, then we'll see the exact words which they have mentioned. So this is the one of the trees given to us, okay? So what they're asking to do is see, starting from the root towards the leaf, okay? What is the root, by the way? Root is the topmost element in the tree. Similarly, what is the leaf? Leaf is the last element, okay? That is the bottommost element in a tree, okay? When I say bottommost, it doesn't mean lengthwise. See, bottommost means leaf is a element, that is leaf is a node which does not have any children, okay? As simple as that, okay? That is the terminating end of a tree, as simple as that. What you have to do, see, we'll have to try to form numbers here, okay? That is C, starting from root going toward the leaf. In this case 1 and 2. So 1 and 2 forms the number 12, okay? Similarly 1 and then 3, so 1 and 3 forms the number 13. So we'll have to basically add 12 and 13, okay? That's what they're trying to do here, okay? See here, 1 pointing to 2. See, we are starting from root going towards all possible leaves, okay? In this case it is 1 and 2. After 2 we are stopping because there is no children, okay? So we are stopping at 2. So this becomes the number 12. Starting from 1 ending towards 3, this becomes the number 13. 12 plus 13 is 25 and that is the answer. We'll see another example here. Starting from 4 and see what are the leaves here, by the way. 5, 1 and 0 are the leaves, okay? So starting from 4 we'll have to find a path towards these leaves and then we'll have to form a number. So what are the numbers possible in this case? Starting from 4 till 5, okay, it becomes 495. So 495 is one of the numbers. Starting from 4 ending at 1, so 491 is another number. And starting from 4 ending at 0, so 40 is another number. Now you'll have to take the sum of all of these and you have to return in the answer. So now let us see what is the exact terms which they are using. You are given a root of a binary tree containing digits 0 to 9 only. Each root to leaf path in the tree represents a number, okay? That's the same thing I mentioned you. For example, root to leaf path 1, 2 and 3 represents the number 123. Return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in the 32-bit range, okay? So see, in C++ and Java, basically when you are coding it, integer is represented by 4 bytes. Okay, so each byte has 8 bits. So in total, we are given 32 bits. Okay, that's why this thing they have mentioned. This will be very relevant if you are using C++ or Java. But we are going to do this in Python. And here we are not, we don't have to bother about these things because Python is something which will be, accommodating by itself. So if the number is larger than this, it will allocate the memory by itself. Okay, dynamic allocation. Yeah, then the thing is, a leaf node is a node with no children. The same thing I've already mentioned you. So if you have any doubts, anything, see, I will give the link of the question in the video description. Go click the question and just try to understand everything. If you have any doubts, please do let me know. But I'm sure that I have explained every possibility of this particular question. Okay. So this is very clear. Starting from root, we'll have to find a path towards the leaf. And then while doing that, you will be traversing certain nodes, right? In this case, it is 1, 2, and 3. So when you do that, it forms a number. Okay, which is 123. Okay, that number, such numbers we have to collect, and finally we have to return the sum of them. So now coming to the code of this particular question, I am declaring an answer which I will be see, for each root to leaf path, certain number will come. I will add that number to my answer. As simple as that. Then I am defining a DFS function. This is going to be a DFS function, and this is going to be the function call. Let us see what is there in the DFS function. Okay, this is the DFS function. Next, what I'm doing, if r is none, return. This is going to be the breaking condition or the base condition for the recursive function, and this is going to be the this is the breaking condition, right? Next, what I'm doing, see, there are two things here. First is going to be the root and which I'm going to start the DFS. Second thing is the sum. If sum is not provided, it will be taken as 0. Okay. So let us say how I'm calling the function. I'm calling it root and 0. That means when I am this particular node 1, the sum will be 0. Okay. What I will do next, I will do sum into 10 plus r dot value. That is 0 into 10 is 0, 0 plus 1. In this case, it will become 1 only. Okay. So the sum is 1 in this case. What I will do next, I will do defs of that is I will call the defs function for the left subtree, and then I will call the defs for the right subtree. At the same time, I'm passing the current sum, which is 1. Okay, which is 1 in both the case. Next, see, remember this condition is, see, this condition will happen. This condition will be true only for the nodes which are leaf. Okay, what is that? When r dot left is equal to none and r dot right is equal to none, only then this condition will be executed, and this is true only for the leaf nodes. Okay. So then we'll come at, okay, let we are calling it for the left first. Okay, so from 1 we are coming to 2. When we come to 2, what is going to be the sum? That is what is going to be this particular value. This particular value will be 1 now. Okay, so what I am doing now, 1 into 10, which is 10, plus r dot value, which is 2. Okay, 10 plus 2 is 12. So sum is 12 now. Okay, now this condition will become true because 2 is a leaf node. What I'm doing, answer is equal to answer plus 12. Answer is 0 initially. Okay, answer is 0 initially. Answer is equal to answer plus 12. So answer will become 12 now. Okay, then we are returning it. Okay, because it's a leaf node. Then what will happen, we'll come back to 1, and once we come back to 1, we are going to execute this part of the code. Okay, so that is, it will call the refresh function on the right subtree. Okay, in this case it is 3. Okay, it will come to 3. Again, remember, when it comes to 3, the sum is going to be 1 again. Okay, it's going to be 1 again. Okay, what we are doing here, we're doing the same thing. 1 into 10 plus 3. Okay, r dot value is 3 here. Okay, 1 into 10 plus 3, which is 13. Okay, sum is 13 now. Again, this condition will become true because in this case 3 is a leaf node. Okay, what it will do, answer is equal to answer plus 13. Answer is already 12, so 12 plus 13 becomes the answer. Okay, then we are going to return it. It's the return. Then ultimately the this recursive function will end, will come out of this, and finally we're returning the answer, which is going to be 12 plus 13, which is 25. So let me quickly run this and show it to you. As you can see, this is clearing all the test cases, and I've already submitted this solution and it works. So this was, a basic, see, the idea here is, we are doing a basic traversal, but at the same time, we have modified the question in such a way that it doesn't appear that we are, doing anything, basic. Okay. But the fact is we are doing a basic traversal, but while doing the traversal, we are also calculating sums, and we're, adding it to our answer. As simple as that. So often that was this. And if you're wondering what is this non-local of answer, see, in Python, it is always better. See, the idea here is, you will not be knowing which platform you will get for your coding interview. That is for your online assessment or your coding interview. That's why it's always better to write this non-local answer. What that means is, see, if you're not declaring anything in the function, but we're using it in the function, it's better to declare it as a non-local variable. Okay, because answer is declared outside the scope of the function. So that's why I'm calling it as a non-local here. What happens is, some of the compilers will see that answer is not declared, so they will assign a value of 0, and they will start using it. Okay, so it's better if you're using anything which is outside of the function. That means you'll have to declare it as a non-local. It's a very good practice, and it will be really benefiting for you if you are, see, in Python what happens is, it's not like C and C++. Okay, there are slight differences here. That's what it is. If you're not doing these things, then I'm sure that in an interview you will be stuck in a position where you're not understanding why the program is behaving in a certain way. So these are some of the basic things which you should have understood while learning the language. But anyway, while coding, you should be knowing these things. So yeah, friend, that was all for today. This was on the easier side. That's why I've said in the starting of the video itself. Please let me know your thoughts in the comment section. And if you like my efforts, please do consider subscribing to my channel. It really gives a lot and lot of motivation to continue further. Thanks a lot. See you tomorrow.